Today I want to cover a subtraction trick that's really useful when you're subtracting from a power of 10. So numbers like 100, 1,000 if you're subtracting a quantity from those numbers. Now the traditional method involves something like this. We can't take away 6 from 0, we can't take away 3 from 0, so we're going to have to make this 0. We go down 1 here, up 10 here. So this becomes a 10. So then now we have to go down 1, up 10 again. So, a lot of kids get confused with all this carrying, So 10 minus 6 is 4. 9 minus 3 is 6. And, we could leave the 0 alone. So in Vedic mathematics, what they do is they tell you take all from 9, last from 10. So let's do a similar example using that. It just automatically makes it in the 9, 9, 9, 10 format, It just conveniently takes care of this. So watch this. 100 minus 27. Now, all from 9, last from 10. So we take the number, this number, the number that we're subtracting, and we have to say, what's 9 minus 2? That's 7. And then our last number is 7, so we have to take 10 away from 7 now. 10 minus 7 is 3, right? And this can be extended. Let's take a number away from a power from 1,000. So 1,000 minus, let's say, 2, 4, and let's say 7. So now, these are the three numbers I'm interested in. All from 9, last from 10. What's 9 minus 2? That's 7. What's 9 minus 4? That's 5. This is the last number, so I have to say, what's 10 minus 7? And that's 3. Okay? Let's move on to another example here. Now I want to make a point here. So let's say I have 1,000 again, minus, let's say, 42. Now, it's important that the number of digits in this is called the subtrahend, the number you're subtracting, is equal to the number of zeros in the minuend, this number right here. So if I see 3 zeros here, I should see 3 digits here, which I don't see, so I'm going to have to add an extra 0. Now I can apply the all from 9, last from 10. So 9 minus 0 is 9. 9 minus 4 is 5. 10 minus 8, since this is the last number, is 8. So my answer is 958. Okay, another thing that I have to mention is that if we have an example like this, let's say 1,000 minus 670. So this is kind of like 100 minus 67. In this case, since we have an extra 0 at the end, we're just going to bring it down first. So this counts as our last number. So it's really the first non-zero number from the right. So 9 minus 6 is 3. 10 minus 7 is 3. Okay, let's do a couple more. Let's just extend this, all right? So let's say 1,000,000. That's 1 followed by 6 zeros. Let's say minus 54,230. This is a good example to really understand everything that's going on here. So here's the way I think about it. First of all, I need to add an extra 0 here because the number of digits here has to match the number of zeros here. So first thing I'm going to do is add a 0 here. Next thing I recognize is I start from the right. First non-zero digit is 3, so that counts as the last digit. So I just bring down the 0, all from 9, last from 10. What's 9 minus 0? That's just 9. What's 9 minus 5? That's 4. 9 minus 4 is 5. 9 minus 2 is 7. And here we have 10 minus 3 is 7. So what's my answer? 945,770. Okay? Let's just do one last example because I just want to make a minor point here. So example 7. Now, you can also think of this in terms of addition. You know, what I mean by that is, let's take 1,000 minus 6, 8, 4. So all from 9, last from 10. This is the last number here. So instead of saying 9 minus 6, you could also think of 6 plus what number is 9? Oh, I'm going to say 3. 8 plus what number is 9? I'm going to say 1. 4 plus what number is 10? That's 6. So, in my opinion, this method should be taught. I mean, it's so much easier. And a lot of kids get confused. You know, don't forget in example 1, it takes care of all this needless work, okay? So, and it's also easy to remember. All from 9, last from 10. When is it useful? For subtracting from a power of 10. So 10, 100, 1,000. And a small variation could help you subtract from numbers like 2,000, 20,000, but I'll cover that in a different video, okay? Great job.